You're welcome to Zishan classes. Today we're going to look into another question from kinematics. The problem is that there's a wedge upon which a small mass m is placed. The mass of the wedge is capital M, the angle is alpha. We have to find the acceleration of the wedge with respect to the floor, the surface. There is no friction. There is no friction. We should keep in mind that if this block moves a distance of 1 inch or 1 centimeter downwards, this block is pushed the same distance towards the right. If this comes down 1 centimeter, this moves 1 centimeter that way, which helps us come to the conclusion that acceleration of m, the small mass, this way is equal to the acceleration of the capital mass m this way. So we'll use this concept, we'll name this A, we'll name this acceleration, which is equal for both, as A. We'll use this concept to solve the problem. First, we will deal with the small mass m. This mass m has an acceleration equal to A downwards. Also, it is moving with the wedge m to the right. The acceleration of wedge is also equal to A. So we have two accelerations of the mass m, small mass m. We'll write the equations separately for these accelerations. Also keep in mind that this angle is alpha, which helps us write this acceleration into two components, A sin alpha and A cos alpha. We have broken A into two components, A cos alpha and A sin alpha. We will write the equations of motion for the small mass m. First, in this direction along the plane. It's going to be mg sin alpha minus t equals ma minus ma cos alpha. This acceleration A in this direction and the component of A in that direction result in ma minus ma cos alpha here. We will talk about the acceleration in this direction perpendicular to the plane. The forces acting in this direction are mg cos alpha and minus r equal to m times a sin alpha. Now we will talk about the wedge capital M. The forces acting on it are the tension this direction, the reaction which it applied on the small mass m, it's going to act in the opposite direction on it, R. This angle is alpha, mg and r1. So we will, and it is moving in this direction with an acceleration A. We'll write the equation for the motion of this body in this direction. The responsible forces are T. T can be broken into T cos alpha and T sin alpha. We'll use the T cos alpha, which is in the opposite direction. Also, R can be broken into R cos alpha downwards and R sin alpha that way. We'll use that component R sin alpha equal to MA. Now we will use these three equations with unknowns R, T and A to obtain the value of A. To obtain the value of A, small a. So we have three equations and three unknowns. There are various methods by which you can get to the value of small a, the acceleration required. It's a long procedure to get it. I don't want to write that all. You can solve it by yourself. In case you have any issue arriving at the value, you can tell me, but I can give you a hint that you can eliminate T and R from using these equations, and you'll arrive at acceleration is equal to G sine of alpha divided by M plus 2 into 1 minus cos of alpha. Okay, this was the acceleration required, and that's it. I'll see you in another video. You have a good day. Bye.